All right, we just got a T590 in the shop that has drive motor issues. It's got a different issue on each motor, so I figured this will be a good learning opportunity of how I go about doing some tests on these, trying to diagnose whether it's a drive motor or if it's a pump issue or something else is going on. But since we got two different issues, let's look at the symptoms real quick and then we'll go over what I think is wrong. Then we'll tear it down and see what is actually wrong. I'm gonna crawl in here. I'm gonna go ahead and unplug my door sensor so that we can leave the door open. Okay, so I got the machine started and I released to the brake. Bring this bucket up just a little bit. And I'm gonna push forward on the left side. So I'm in full forward motion and the track is not moving. And again, I'm at low idle, yeah, but the track should be moving in this forward direction. Now let's do this side. See, that track pulls no problem. But this side has no power. Well, it's got a little bit in reverse, but barely anything in forward. So now what I'm gonna do is I'm gonna set my parking brake. And now neither track should be able to drive, but on this right side, I can still drive with no resistance. Usually you'd hear the motor bog down or something. I should not be able to drive with the brake set on that side. The left side, same thing. I have no forward motion. I got a little bit of reverse power, but I can drive right through the brakes. So let's look for some things that might have caused that issue or go through some testing procedures real quick. So first thing I want to do is I want to pull out this hydraulic filter and we're going to inspect it for clues. Let's see if there's any metal or anything in there. So these caps kind of suck to get off, but let me see if I can persuade it a little bit. And this does look like an old style cap to me. We have upgraded, kind of changed the hydraulic filter on these since this cap, but we'll see once we get in here. And then we're going to pull this filter out and we're going to put it in this clean pan here. We can see this is the old style filter housing. Okay. Now this filters from the inside out, so I want to try to, and this oil is pretty black, but I'm going to pour it from the inside onto this clean towel and see what we get. So not what I wanted to see at all. It's actually brass colored metal in there. I was hoping that it would just be all steel and not brass. And we'll talk about why that is later. So we can look at our pumps and we know that we have low power on the left side of the machine. So I'm starting on the left side here. I disconnected the main drive lines. We capped those off, or put plugs in the drive lines, and on the motor I capped one side and then we've got a test port down here on the other one. Ideally I'd like to have test ports on both of them, but we're just going to do one at a time. So we'll plug our gauge into here, we'll start the machine, and we'll just deadhead it into the gauge and just make sure we're making pressure on both sides of the pump, because if we're making pressure on both sides of the pump, we should have drive on that side if we had a good drive motor. Alright, so I got the machine started and running, and we can see that we've got 300 psi roughly on the gauge now. And that is charge pressure. Our whole system is automatically, when you start the machine, the pumps, the motors, everything gets charge pressure. So that's why we're seeing 300 psi right away. So our weak drive on this is in the forward direction. So I'm going to go ahead and move my lever forward 1,000, slowly moving it forward, 3,000, 4,000. See, we made 5,300 psi, and we're probably going over relief at 5,300 psi. At that point, we talked about high pressure release in another video. So that tells me that this pump is making plenty of pressure to move that drive motor in the forward direction, but the drive motor just doesn't have power. So I'm just testing the forward motion on this drive pump, because if you got pressure forward, more than likely you're going to have it in reverse too, because if there was internal damage in the pump, you wouldn't have it in either direction. So I could swap the fittings and check reverse, but I don't think I need to do that. There's plenty of pressure in the forward motion, so we know the problem is in the drive motor. So we're going to go ahead and get the tracks tore off and get the drive motors off. But before we get the drive motors off, we're actually going to check the brake circuit using our Porta power. We'll show you how to do that too. So we know the motors are coming off, but we're still going to do another test just to see how to do it. We are going to test our brake circuit using a Porta power. Now, I had to make an adapter fitting here, you know, to go into the brake circuit. But, you know, on this machine, you know, we've got our main drive hoses back here going to it, and then we've got two smaller hoses. Now, this one here goes to our case drain block. So we got case drain oil. Everything goes to this block through the cooler back to the filter. Now, this valve down here is our brake valve. So what happens when we release our brakes, we energize this coil, which allows charge pressure to enter the brake circuit. And now you can see that there's a T right here. So one's the left motor and one's the right motor. So we send charge pressure to both brakes to release the brakes. Now, the brake circuit does not flow. It deadheads. So we should be able to pump this up, push that brake piston in, the seal will hold the oil, and basically it releases the brake. So that charge pressure just holds the brake open. There's no flow through that circuit. So when we pump up our Porta power here, what we would do is push that brake open and hold it there. And we can let off this. Let me get over here. We got a little gauge on the front. Now, we don't want to go much more in charge pressure, but we can easily do 500 PSI in that brake circuit to see if it actually holds. So as I pump this up, see, the gauge is not moving. And I'm just pumping oil into that brake circuit. So that tells me that the oil is bypassing the brake piston going somewhere. Well, where's it going? So we'll see where it's going. So this is the case drain hose coming off the motor. So if it's bypassing the piston, it should be coming out this case drain hose. We will cap off, you know, the case drain manifold so we're not getting oil out of there. Okay. So maybe we can see this. Now that's just residual oil kind of dripping out of there. So I'm going to take my pump. I know I'm a little off camera, but you'll just have to take my word for it. I'm going to start pumping up the brake. And look at that. The oil just comes right out of this charge hose. So every time I pump oil into there, it's just bypassing that brake piston coming out. Did I say charge? This is the case drain hose. So that tells me that, I mean, the piston's not even holding. And like I said, we're just doing one drive motor here. We can also do the test on the other motor, but I'm pretty confident that that one's going to give us the same result because that brake's not doing anything. And I don't know, I might test that side just to see, because that doesn't mean that the brake's bad. Since that one's not holding, it could be just the brake disc or shot, and it doesn't make a difference because there's no brake disc left in there, so it doesn't make a difference if we pump it up or not. But either way, both motors are coming in. That's how we test the brake circuit, by pumping in, you know, charge pressure or hydraulic pressure using a Porta power into the brake circuit and seeing if it comes back out of the case drain circuit. And the other test that we can do that I'm not going to do right now on camera is what we call a case drain test, because you've got to know what the actual specification is on that. We would just take that case drain line off and we put that into a bucket, start the machine, and see how many gallons per minute is coming out of the case drain. You know, it should just be a low, slow flow, like a gallon a minute or something, but if you get any more than that, and we have excessive case drain flow, then that tells us there's something wrong inside the motor. But we already know we got motor issues, so we're not going to do the case drain test on this. We're going to go ahead and rip them off and see what the problem inside was. So hopefully all those tests make sense. You know, what we do, we check the filter, we tested the brake circuit, and then there's a case drain test, and we tested the pressure on the motor. So all signs still lead to the motors. That's why we're pulling them off. Here we go. So we've got the drive motor out, and we're looking at the left-hand drive motor. So I went ahead and washed it off to kind of avoid any contamination I can get in there. I hate tearing down dirty drive motors, especially if we think we can rebuild it. So we're just going to go through. We're going to start with the brake section. We're going to pull this plate off, and then we'll take a look at the brake seals and see what the brake section actually looks like. But I think we're going to have damage in here. Now we got top of our brake off. This is the Bellevue washer, we call it. This is the actual spring for the brake, because these brakes are spring applied pressure release. So it's not like a normal, I guess, spring you would expect. It's just like a concave washer that actually, that's all the spring pressure going on that piston, but there's no oil on top of it, which is good news. Now we've got our brake piston up here in the top, and it is threaded, so we could put a bolt in there and we could pull that out, but I like to use a little compressed air. Compressed air on hydraulic systems is dangerous. See how that just lifts that right up. And this is our brake piston seal, but it looks okay on this one. So I'm trying to get my brake housing off, but it's not, I mean, it should, with no pressure on the brake disc, it should just slide right up, and this one is not coming off very well. So that tells me that there probably is some damage to this brake system. Now the brake seal, you know, we have a piston seal on the piston, then we got another seal right here that contains that oil on the brake side, and it's, yeah, this seal is completely blown out. There's all kinds of seal material down in here. So we know that that seal's blown out, and looks like we're gonna have brake disc issues as well. If I can get this off, we'll take a look at it. And we can see how these brake discs are just, they were definitely riding on each other. I mean, it's not catastrophic. I've seen a lot worse, but they did definitely get really hot. So they were running with pressure on them. There's no doubt about it. So it's not a catastrophic brake failure, but it did get really hot. Like we can see this seal down here. I mean, almost like melted in there. It is nasty. So this is our brake drive shaft, and I've never really seen one that burn up. So these got really hot, although the brake packs did not come apart, because usually that's what happens is they shoot metal all through the system once these just, they shred themselves. And when we looked in the hydraulic filter, that's the metal I was looking for that I did not see. So although these were hot, they're burn up like a burn up clutch. They didn't come apart and send metal through the system. So that's kind of good news. All right, so now that we got the brake section apart, we know that we got a bad brake seal. Let's just go ahead and pull the motor section itself apart. Now we're down to our cylinder block and our pistons, and what we're doing is we're trying to find out why this has low power. This is our cam section. What I'm doing is I'm inspecting the inside of the cam section that our pistons run on. And there's machining marks in there from the factory, and we kind of know what to look for on those. They're kind of wavy. And this one looks really good, so I don't see any issues, I guess, with the cylinder block itself. The distributor is still inside here, and I'm looking at where the distributor mounts to the surface of the cylinder block here. We're inspecting that surface, and that looks really good as well. I also look around the top of this cylinder block, you know, looking for any hairline cracks or anything, and I'm just not seeing anything obvious at the moment. So we'll go ahead and pull our the cylinder block out. So with the cylinder block out, all we have left is our hub section. You know, this is where the sprocket bolts to. We've got the inner bearing here that is lubricated with the hydraulic oil, but the outer bearing, this is that real expensive synthetic oil where we put in these plugs right here. That's what lubricates just the outer bearing on these hub faces. So we'll double check that oil, but there's really nothing else wrong with the hub section, so I'm not going to tear any deeper into that. So we'll just set that off to the side. We're going to inspect the pistons in here because each piston has its own seal. Okay, so there's a clip on both sides of the cylinder block, and we'll have to remove the clip from both sides to get those pistons out. And once we get those snap rings off, we just have the upper and lower collars here. And now we can push these pistons out. We want to inspect them the same at the each individual one, because we want, you know, each piston should stay in its original bore. So I'm just going to do one at a time using a little compressed air in the distributor hole, and that'll kind of just push the piston out for us. And it's hard to see, but there is a little seal on here. It's like a split seal. So it's not cracked, but, oops, dropped my bearing. But there is a little split in there. And you can't buy that seal individually. You have to buy the whole piston as a complete unit. I'm looking, I've got some really weird wear on the bottom of that piston. I'm not sure why. So I'm just going to work around and inspect each one of these, like I said, individually, and see if we see anything obvious. So after inspecting our cylinder block, I just don't see enough damage to make me think that there was a problem, you know, inside here. So we are going to, we're going to check the shuttles, you know, in the pump body itself there at the distributor section, and see if maybe there was, I don't know, something going on inside there. So I've taken all my shuttle pieces out and all my springs, and I just don't see, you know, anything obvious that would cause that low pressure, you know, other than we got some blown seals. So maybe we're just losing enough charge pressure out of there, and the charge pressure is what feeds these pistons. So maybe that's what the issue is. We're going to find a seal kit, and we're going to get this all put back together or reassembled and put it back on the machine and test it. But I think a new brake pack and a seal kit, and this one might be good to go. So we tore down the right side motor as well, and we kind of found the same thing. I mean, the brake disc are just literally burnt up and just melted together. So again, they didn't destroy themselves and send metal all through the system. However, our brake shaft, you kind of see where the internal disc were slipping, and they actually damaged this shaft. So once we quoted out parts for everything, the shaft and all these brake discs, which are like $30 for each individual disc, it just turned out that the customer just decided to go ahead and purchase new motors. So I just got to get this one put back together for the core. Even though they're new, they still want a core on these. And we just got done installing him here. Got the tracks on. So now we just got to change the hydraulic filters, top off the hydraulic oil, get off the jack stands, and we'll be ready to test it. Well, we just finished testing the machine with the new drive motors on, and what we want to do is just check the brakes and make sure that they were functioning properly, because we're not sure how they drove through the brakes and what caused all that damage, but everything is working properly now. And that's, so basically the whole point of this video was to go through and just kind of the troubleshooting procedures and stuff on there, but the new drive motors did fix the issue on this machine. So any questions, let us know. Thanks for watching.